So I'm getting, I guess, positive results from this. Still with the neodymium magnets placed with mu metal blades on top, causing dips in the field, so turning a single field into something with a flux in the field, and that produces power, as well, every generator works. This is going to show the, well, that's going to be showing the output voltage of the generator, and mind, I'm using 18 gauge wire, steel wire, because the transformers I got the wire from was steel. So the voltage isn't going to be high, because I'm looking for more of the amperage. And with 18 gauge wire, also the lens effect that I'm going to demonstrate here, running from this, well, it is a big battery, but it was chucked out by a site, so I grabbed it. But this is a 12 volt battery anyway. But I'm going to demonstrate that running from a battery, that can just about run this. It's driving this large DC motor. That when I load it and dead short it, there's no lens effects. If you want to argue the case, saying, oh, obviously it's going to run fine, it's a great big car battery. It's running a 12 volt motor, which is what it's designed for. That I'd like to demonstrate that this has a cogging effect, and it isn't actually easy to run, because there's six coils and six spots on the magnet, 3 new metal plates. So there's a plate gap, which is causing the cogging effect. So this isn't an easy to run thing. Just come loose. Let's demonstrate that. From the output of the projectifier, I know it's all bad lighting, but from the output of that, it goes up to this motor here. I'm just going to show that simply that it just produces power, and under load it still produces power, and I'll be dead shorting the outputs, which are these 2 wires here, the blue and the brown one. I'll be dead shorting that and showing it, even running from this 12 volt battery, that this generator doesn't slow down. That's an N52 grade neodymium magnet inside there. It should slow down, because it's going to obviously produce a large magnetic field and indeed interact with other magnetic fields in a very, very strong way. Normally they'd slow down, but this one doesn't, and I'll demonstrate that. So mind if I just set this up? It's not going to be pretty, because I've got a great big wrench on there. As you can hear, the motor isn't running that fast at all. Under load of the little motor up here, which is spinning, under load it's producing 3.9 odd volts. As you can see, it's here as well. It's not running that fast. Holding the motor still, as shown by the tab. Nothing. And now I'm going to short the outputs from the projectifier over there. You'll see the motor stop, in case that actually goes on it. As you can see, the motor comes to a stop because I've dead shorted it here. Despite the fact that a battery is running this, and it's not running in that fast. There's been no lens effect. You see the motor switching. We're dead shorting it and releasing the connection. And I can also show a dead short, sorry, yeah, on here. Separating the 2 wires. and dead short on it. So I'll do the backing camera. Dead short. Absolute zero. Motor's obviously come to a stop. No effect on this whatsoever. It was a battery running the motor. So far so good on this. Ideally, I'd like to then test using offset blades, because there's a set on the top and a set on the bottom, which is sandwiching between the coils. Again, bad lighting, but that's the stator, as it was to pick up a bit of metal for the coil, which are in, use that white one, it's easier to see, two halves, so that the north field comes out, goes around the outside, fluxes through, and to the south side, so flows through the actual coil. And with that, obviously produces power. So the stages after that will be, again, having offset. So there's a plate at the top but no plate at the bottom, to see how that fares. Then ideally after that is to test straight coils, which is your normal traditional long cylinder coil, between two magnets, because I've got a second one over at the side and some more blades, so I can build a second rotor. But again, before that, because of this cogging I've got on here, I was going to have a secondary set of coils, so one coil and two coils on the bottom plate, which is a MDF board, really bad lighting. Yeah, there's enough room there to actually set two coils and have one magnet with like 3 blades, the other one with 3 blades, but offset by a rotation. So instead of it being metal, which is at the top, this one would be metal, this one would be the gap, and the gap down the bottom. As if that makes sense. So far this is metal, gap, metal. So that's the metal, gap, metal. So then repeat that downwards, and the magnetic forces will hopefully counteract each other, so that they can't neither push nor pull, because they're working against each other at 0 point energy cost anyway. And the only gain from that is no cogging, which will increase the speed of the motor, increase its efficiency, higher voltage output, higher amperage output, and I'll be connecting the two sets in parallel so that the voltage remains the same, amperage increases because it's a workforce. Voltage is volume and amps is workforce behind. That's why amps can kill you, not voltage. You could be hit by 10,000 volts, which I've had, and it fucking hurts. But it didn't kill me. Left holes in my fingers, but yeah, it didn't kill me. But obviously amps would, so that's what I'm actually after. That's why I've chosen 18-inch gauge wire to load this down as much as I can. But obviously with this, so far so good. No lens effect or no loading effect. Ideally I need amp meters, I know this, so the draw from the battery to the motor, but I don't have them. The only range on this one is what, 250 milliamps, but that's jack. There's nothing, so that's a 36 amp hour battery. And the size of it anyway, just blow it up. But yeah, demonstrating so far that I'm working with no lens, and it's been a success. For now anyway. Alright, now take care.